with Janine Benyus and the Biomimicry Guild, back when it was around, since about 2010. We've worked with Biomimicry 3.8 quite a bit through our Project Positive effort, which sort of joins forces between HOK, Ecometric Solutions Group, Jacobs, and B3.8 to really try and create these nature positive examples. I'll share a couple of those with you today. And then obviously with the Biomimicry Institute as well. I've known Amanda Sturgeon for about a decade now. And so really wonderful to always be providing a bit more research to deepen our work, receive so much of the information from your network that guides a lot of our process, whether it's inspirational, technical, or just unique inquiry that sort of say open synapses that weren't connected previously. So happy to be here.
That's a good description. And I'd love for you to give a quick intro to how you got interested in regenerative design and biomimicry, and how you would define regenerative design and biomimicry. Are they the same? Are they different?
Yeah, it's a great question. So I have been interested in biomimicry probably dating back to about 2008. I wasn't with HOK at that time. It was actually about the first time that I think HOK began to start a formal partnership with the Biomimicry Guild. And it sort of opened my eyes to some of the opportunities we had to look at the challenges that we face in the built environment. And how has nature sort of responded to those challenges? How do we sort of begin to sort of create unique, inspiring new ideas, technologies, or even systems to emulate? And so biomimicry became that sort of wonderful lens for me to sort of start thinking, not only how do we be inspired by nature, how do we really start thinking like nature? How do we understand those systems and begin imprinting that into our work? Over the course of the past 15 years, I've been able to do that work. We've come up with a lot of solutions. Some of them are regenerative. We're actually producing more ecosystem services than the native habitat, but I would use sort of the short-term definition of regenerative design, and I'll dig a bit more deeper into that. Well, some pieces of biomimicry are just advancing technologies. They are still doing less harm, and so they are sustaining or conserving. And so biomimicry, I think, no matter what, becomes a really key methodology to it, while regenerative design is a more overarching framework to achieve nature positive impact.
That's awesome. Thank you for the clarification. And without further ado, I'd love for you to show us some of these examples and kind of talk us through the projects that you're excited about, that you got to work on, and that are creating these really amazing outcomes.
Absolutely. Let's see how I can share screen. Let's see if this starts to go. No.
Fingers crossed for no technology issue.
All right. Let me know when you guys see a big screen that says regenerative
people can
design,
give a thumbs up if you see this.
Resilient cities. All right. Technology works. Wonderful. Not always the case. So I'm talking to you. We founded the Regenerative Design Studio at HOK back in 2020, sort of around the period in time when all of us kind of got stuck at home a good bit. It uniquely allowed for a little bit of deeper thought process into some of the work that we were doing and how do we begin to connect to nature better. As we began going back to 15 years ago, we started seeing cities become the most, the biggest centers of population around the world. We began seeing the biggest degradation of the natural environment. So how during a period where we were sort of isolated from each other, people started going back into nature, we began to rethink a bit more about how we create buildings, how we create cities, and how we begin to rewild them. And so while HOK has been involved in integrated design, sustainability, net zero energy, water and waste projects for more than 30 years, this became a really important moment for us as a practice to reimagine what would it mean to go beyond zero to be nature positive. So with that, we asked a number of questions, and I guess the next technical thing will be, we'll see if this video I share has sound. So give me a thumbs up in a second if you all can hear it. Sound? No? Oh, no.
Yeah.
Is there any sound with that? No worries. I will.
Cool visuals though.
I will have to be the voiceover to it. Let me just double check and see if there's any way. Do you know if there's a way to share sound within this environment?
I think when you initially share, there might be a button to share screen sound.
I see. I'm going to stop my screen share for a second and just try that one more time because it came up pretty easily. Also, share tab audio. Yeah, it should have. If not, I will be the voiceover. I'm just trying to keep pace with myself. All right, one last quick audio check. If not, I'll do it myself.
I'm still not getting sound.
All right, no worries. All right, I'll do it. So let's see if I can get the video back. Come on, you can do it. Here we go. What if vigilantes function like a forest, generate more energy than it consumed, in rainwater, improved air quality, captured carbon, enhanced the health and well-being of people and nature? It can. That is regenerative design. So regenerative design really arose out of our practice, which, across HOK, as Lily noted, we are a global architecture, engineering, planning, and design firm, which means we have a lot of different disciplines and a lot of people that are trained in a lot of different techniques. The best parts of our work occur when we begin to start playing in each other's sandboxes, where lessons learned from one discipline or lens begins to inform the other one. We grow into a transdisciplinary practice from a multidisciplinary one, when that allows us to really reorient things. We aren't only asking for advice when it's appropriate, we're constantly collaborating. And so this sort of notion of sustainability at the heart of it has always been a key reference point to us as a key value point. How do we create the best healthcare opportunities by creating healing environments? How do we create nature-based learning environments? How do we reinforce hospitality or create campuses that incorporate natural systems? When nature gets put at the heart of that, and we start to coordinate the sort of mutual prioritization of the core and the whole, regenerative design becomes possible, because every decision that's being made puts life at the center of it. That methodology really takes the practice of systems thinking and layers on ecosystems thinking into the front of it. So it's ensuring that we are continuously engaging the healthy relationship with the environment, building in people, and it follows through this emulation of natural systems that exist within a region, inspire reconnection of the community to nature, and aim to create mutualistic benefits between nature, building, and people. Simply put, regenerative design gives new life to something that has been depleted, and it puts life at the center of every decision, action that we make. The evolution of this concept, dates back about 25 years to Tasmania, really coming out of regenerative agriculture and permaculture. This isn't a new concept that HOK has invented or any individual has. The resources I share here are actually developed by Bill Reed and the Regenerative Institute. This comes from a concept of moving beyond where we were in the 1970s up until about the early 2000s, where we knew and recognized the degenerating or degradative effect we had on the environment. We started to institute, new building codes and standards that would enable us to at least limit that harm. The green building movement began in the late 90s through the introduction of certification systems, performance requirements, and that really sort of began to establish a more progressive means by which we were conserving better. As we've kind of moved forward in the past 10 to 15 years, this goal of net zero energy has arisen, now the goal of being carbon neutral. But all of that positions ourselves to a point of still being less bad, or at best, being neutral. And I don't know about you all, there's nothing I've ever done in my life that I've just wanted to be less bad at or to be neutral about. I've always wanted to do better, to learn more, to thrive better, to support my family, my team, and engage in my community. We never want to just break even on our budgets. We want to earn profits. And so nature wants to do the same thing. And shouldn't we think about natural systems in that same vein? And so the first step that we have to move towards positive means we need to restore the damage that we've done into the natural world. How can we restore pre-development environmental conditions? The notion of being regenerative means that we are able to produce as much ecosystem services or as healthy of a habitat as would have existed without human intervention. And so it asks the most important question: how can humans actually create a positive impact in the environmental world such that it's doing better because of us, and that the ultimate effect is that human and natural systems begin to co-evolve as one. Right. This is really important, both beyond the sort of overarching climate conversation that we've been having for more than 20 years now about the rising temperatures, and the atmosphere, and focuses a little bit initially on the biodiversity loss that's been going on, and that over the course of the past 50 years we have seen the greatest degradation and species diversity around the world. Beyond neutralizing our temperatures, if we only do that, we're left with a world that will still be in less better shape because we'll have lost some of the most important assets that actually become, I think, a pretty key inspirational point. I don't know about you all, but it is a little bit hard to communicate and create an emotional attachment to a temperature or the amount of carbon emissions. But each and every one of you that's in this hive has a story to tell of your personal experiences within nature, with your family, with friends, maybe your partner, within the environment. And that's something that I think is a really key asset, and that gets to the heart of ecosystem services. Nature has provided for humanity all the assets that we need to thrive. And so it becomes really incumbent upon us to become the most appropriate and responsible stewards of that. And so we've sort of worked as a practice over the past few years through Project Positive, a partnership that was started by Biomimicry 3.8 in 2019 to really begin to demonstrate to companies how we could drive innovation, support climate goals, and engage employees as well as local communities using a programmatic and data-driven approach that's inspired by nature to achieve positive performance. What that looks like is this: that at the beginning of any project, any individual building, development, or longer or larger scale planning effort, we want to identify and really understand the local context and conditions of a place and or site, really understand the natural systems, what makes that genius of place really thrive. We then want to quantify what the baseline performance is of the sort of immediate confining areas that we're going to operate in. How is it performing as a habitat? What is its biocapacity? And how is a local ecosystem doing? Can we identify a thriving reference ecosystem, or even better, can we identify an ecological node or area that becomes a little bit of the keystone space by which all other pieces of the ecosystem shed from, or are we feeding into it? Once we recognize and identify that gap, we can start creating these design guidelines and strategies to emulate ecosystem performance metrics. And so this is where we get to have the most fun, that by studying nature and the place and how people organize in that environment, how can we solve the problems that are there, but also do so in a design that inspires social connection, natural connection, and long-term resilience to other forces that might threaten that, be it natural or social. And ultimately, we need to work with our clients, contractors, developers, as well as the community to implement that change. And that requires a deep level of understanding and especially commitment. We can deliver you a building in 3 to 5 years. We can't deliver a natural habitat in that time, right? It takes that much time to plant it, but trees take a long time to grow. When we talk about nature positive impact, it's a 10 to 25 year commitment to establish that change. And so what we're diving into that is not only through the notion of biomimicry, creating these sort of bio-inspired ideas, but really digging into ecosystem services. So we're doing a lot of work, especially with our partners at Ecometric Solutions Group, or EMX, using their tool, Ecosystem Intelligence, to quantify nature's benefits and really identify these what we call ecosystem service cascades. And so from the left, working from the bottom up, like how we might normally read a graph here, we want to identify how do we start creating the right interventions, the right regenerative strategies that might help heal the soil at the ground. How do we reinforce water quantity and quality management? How does that produce the landscape systems that enables better air quality, but also begins to allow biodiversity to thrive? Because all the right conditions for a habitat to be formed, have that underlying foundation. Where do we put people into that mix in a way that actually inspires them to become social stewards of that space? And then ultimately, how does that begin to enable carbon sequestration or other climate regulation? The way that we measure that through an ecosystem service cascade is to understand the attributes that occur in those different landscape interventions. What function do they provide? And what's the extent of the production possible within that ecosystem or portion of the biome? And that those ecosystems flows recognize that one single move has multiple attributes and benefits. And that's how we can summarize these out as values. And so the notion here is, how do we actually create a value add, an upward moving chart, rather than the typical climate drawdown that we often talk about, trying to minimize our impact. This is how we not only mitigate the climate harm, but we adapt to it and try and heal the damage that's been done. So to give you a couple of examples of where we've done this in practice, and going back to, I'd say, a period of, we'll sort of say, a little bit of naivete in this. I joined HOK in 2010, and one of my first projects was the St. Elizabeth U.S. Coast Guard headquarters in Washington, D.C. This is a new 1.2 million square foot headquarters building as part of a greater 275-acre campus in Southwest Washington, D.C. The initial challenge that we were given was really stormwater management across this site. And that the campus that was there had been in existence since the 1950s. It was a highly impervious campus. And so all of the watershed that was going to be coming onto our campus consumed both the amount of water that we absorbed, but also what water we would have to absorb from what was uphill of us. And so with water management being kind of the critical driver here, we began looking at how nature solves for that problem, right? And over the course of the past few years, I use the AskNature network to solve for a lot of the challenges we face. And so the biological inspiration that we met here was beavers, right? Very simple process, but beavers are extraordinary engineers that through the creation of those beaver dams, they're able to slow down water, filter it, and spread it. And so how do we move ourselves from a position of just creating cisterns and trying to push and move water out as fast as possible to one that takes inspiration from that natural design, that a series of upstream barriers will slow water? We want to learn from the biological intelligence and distill those design principles incorporated into our design. So rather than a series of buckets or cisterns that we might store underneath this building, could we put that onto the rooftop of the building, into courtyards and into landscape, so that we can actually take advantage of the kinetic energy of that stream flow to support the ecosystem? So the St. Elizabeth's headquarters, sort of this impervious area that you see here, with forest just directly adjacent to the west by southwest of it. A new building was being constructed that we were asked to come in to try and see if we could actually manage all those stormwater flows effectively directly on site, to avoid additional pollution and runoff into the Anacostia River, Washington, D.C., one of the most polluted water bodies along the East Coast. To do that, I began doing research into the best means of creating green roofs, but what other, amongst our landscape team, what other species might we draw from the whole East Coast ecoregions? So from the Blue Ridge, northern Piedmont, to the uplands and foothills, all the way out to the outer Piedmont, moving ourselves easterly towards the southeastern plains and the mid-Atlantic coastal plains, introduced us to different soils and plant species that we might be able to insert onto this rooftop and within courtyards to both create a multiple layer of filtration, but also characteristic zones that would tell us lessons about that environment. The resultant building and green roof features 450,000 square feet of plants in these sort of native eco zones that represent the ecologically diverse region of the eastern U.S. The roof's gentle connection to the surrounding hillside and its significant size allows it to seamlessly integrate into the natural landscape. While we had come in with the intention of stormwater management, we learned a lot of lessons about a year and a half later as the University of Maryland College Park began to actually come on site and start taking some measurements. and as well as to observe what was happening with some of the biodiversity. More than the trees that we had replanted, more had actually begun to propagate. Deer had begun to migrate across the site, which created a unique maintenance challenge as they got stuck on a couple of the rooftops. A nesting area that had been formed in the admin building, the upper right of this image, had a bald eagle's nest form out there. And so actually had a bald eagle born on this building. The U.S. Coast Guard just loved that as a key win. But as you move, especially through this project, that story of water became sort of the centralizing force. It was what we had intended to really drive forward. What we didn't understand or expect at that point in time was all of these other benefits. We just hadn't considered them yet at that point in our experience or our overarching career. And so as the building steps down, it also provides this wonderful benefit to the people, the frontline workers who are inside of this building. Rather than just looking atop of white roofs, you have these beautiful green roofs that cascade down, looking out towards the Anacostia River and the Potomac. And for the community that walk by this building, it provides this wonderful natural hue that creates this calming force across, about a half-mile walk that you get to come through and see this building rising out in southwest DC. The central retention pond that you see here, the weir or artificial wetland, processes through every ounce of water that comes onto the site, really capping at around 520,000 gallons of water a year. All of that is recycled through the irrigation of the campus. Some of that water is being used towards some of the process loads of water of the building, but essentially put anything that nature needs to thrive is dropping onto our site directly. Just in the past year, we've started to really learn how to kind of measure these results. How do we move from a position of sort of being the accidental benefits to we actually start quantifying and designing towards these solutions? And so ecosystem intelligence is a wonderful tool that allows us to understand the existing pre-development benchmark. We looked at another GSA, General Services Administration project that was built at that same point in time. What does business as usual look like? And it normally results in a significant, more than 50% drop in that sort of natural performance. The work that we did across this site, trying to preserve as much of the forest as possible and then to reproduce its ecological benefit, put us to just about a 3% drop, but a more than double impact from what business as usual would do. And what's notable is that against the reference habitat, when you look at the temperate broadleaf forest without any human intervention, we're operating at about 80% of that. And so this becomes sort of the benchmark of our work moving forward. How can we continuously look to either, when we move into a green area, have absolutely a neutral outcome that actually might enable longer term growth? And as we actually start to see some of these areas of forest fill in, we expect us to actually be able to meet and then exceed that pre-development condition. And over time, in areas that would more appropriately restore, bring that health back to some of those business as usual cases that weren't executed properly by others. The question for us to ask moving forward is, how do we start replicating this methodology and bringing it to scale? If we can do it on one singular campus, how can we begin to have that impact at a much broader area? And so, continuously learn from the temperate broadleaf biome and take those lessons across that same eco-shed. We were challenged in a similar vein to this in Singapore when the Ministry of Health asked us to look at how to incorporate natural ventilation within hospitals, and more uniquely, to create a hospital without walls. And so beyond learning about attributes of water management, how can we learn about air quality, human health and well-being, and how do we interact with biodiversity when sometimes in a healthcare environment, we need to have some barriers. And so we look to the diptera cart forest here, which provides more of an actual habitat than it is an individual species. As we look through the different layers of the forest, we learn lessons about erosion control, water quality management, biodiversity support, air quality, and carbon sequestration. One of our healthcare planners looked at how the healthcare system in Singapore really operated, which is that in any sort of dorm room, which is what's more happening in the public hospital level, you have 6 or up to 10 beds per dormitory instead of an individual patient unit, which we often have in the US. What would happen if, rather than laying those beds out parallel, if we splayed them open? And if we took the entirety of that IPU arrangement and spread that across like branches, began creating a form that, much like the dipterocarp forest tree system would work, began to really sort of flex and move and adapt because of those natural and dynamic conditions. And with that, my team, which really focuses in a bit more into the building simulation efforts, began to really look at how air pressure would begin to influence this. And so something that is more orthogonal and parallel created a lot of the uncomfortable and inequitable conditions that we find within a healthcare environment. Those that are closest to the window wall have good views to the outside, but too much daylight. Those that sit in the middle have good daylight, but they've lost some views. And those that sit back have the worst disadvantage. They neither have daylight views, and now they often are getting cross-contamination of airflow if you open up the windows. By splaying that unit out, we enabled windows next to every individual bed and a pressurized system that pulled air in and through, so it never went over more than the one individual next to it. The resultant dormitory spaces look like this: that every individual has privacy to themselves while still having views to the outside, large plants or even trees outside of those windows, and or views beyond to the skyline of Singapore. The rooftops that extend around the building, create a new oasis within a dense city. And so each of these different plazas and landscape beds become accessible areas for patients and staff practitioners that have extraordinarily stressful jobs. How do we make sure that there's the right balance of what the community can access and what physicians will need themselves? But as a unique opportunity, how does that create that same citywide impact? And so, rather than having this as an isolated campus, this is open and accessible to the public. And so, rather than walking along the highly polluted streets of Singapore, you have the opportunity or the option here to move up to those rooftops and walk along each of those different parks raised up. And so, creating a really proactive form of social health, rather than coming to a hospital to be healed from something from an ailment. How do you go to a hospital and use the city as a means to maintain your health or generate it as better? And so we start seeing a new environment and a new interaction between the healthcare system and the public. For the final example I'll take you to Palo Alto, near San Francisco, where I'm based, to the Center for Academic Medicine at Stanford. What we had seen happen at Stanford over the course of the past really 30 years is some exponential growth as an organization. The red roofed buildings that you see on the bottom of the screen is all of Stanford University. On the left side of the screen, you start seeing more of the white roofs of the School of Medicine. As it has grown, so has the distance between practitioners, researchers, staff, and students. So there wasn't a central place for them to gather, for them to communicate post-surgery that would lead into a clinical trial result or lead into the opportunity to present out to students or their grads to discuss what had been done. And so to the Arboretum, a nearly 100-acre body of land in the middle of campus, wanted to create an environment that engaged nature for a new scientific workplace. The challenge that was given to us from the client was to create an environment where people were better when they left than when they arrived. This is a fairly simple principle that's often used in hospitality, right? This is why you go on vacation. You don't hope to come back from those holidays burnt out. You hope to come back feeling better. So how can we bring people to a place where they can take respite from a stressful lifestyle, but also encourage the activities and interconnections that could really help them thrive? So at the western end of the Arboretum was a existing parking lot. The idea here was to create a campus that wasn't adjacent to the forest, but actually within it itself. How can we actually pull the ecosystem around and through the building so that we could actually create a natural habitat that would allow these diversified spaces for gathering, but also ways to actually improve the ultimate biodiversity of the site, and not hard to do that with a parking lot. So our natural inspiration for this was the coast live oak, the dominant keystone species that we found throughout the Arboretum. As a natural placemaker, a coast live oak creates ecosystems that support a wide range of flora and fauna. It generates a cool environment under its canopy to support entire communities. We dug in deep into the science of how a tree does that, and what's the extent of which we might actually be able to climatically tune or balance the range of temperature as a result of the evapotranspiration process of oak or any tree. And so being able to block out the harsh sunlight and filter that through, creating shade, channeling breezes by the way that we can mass through bodies, even looking at the root system and how much water comes through, and then ultimately the refresh rate of carbon dioxide being absorbed and fresh oxygen, tells us a lot about how we can take a hot day in Palo Alto that's 85 to 90 degrees Fahrenheit and create a condition under the canopy that's 70 to 75 degrees Fahrenheit. So rather than just trying to blur the boundaries between the indoors and outdoors, we wanted to break them open completely. We wanted to create an environment that actually allows us to, spend more time outdoors. So the ultimate success of the project was that by looking at the sort of the daily impact of vegetation and programmatic areas within our plan, we produced 20% of the original program outdoors, meaning we built less. Which, right, most architects, most developers were trying to build as much as possible. But if you want to build the lowest embodied carbon building, if you want to reconnect to nature, build less. Use nature as the place to gather. And so the success of this project was really being able to instill those environments outdoors. As we began to reflect on the success of this project and the others I've shown you and many more, it allowed us through this project really to create a bit of a playbook for us. How do we begin to ensure that we can institute this methodology consistently across? And so I'll share with you a little video that sort of walks through how we do this, and hopefully an approach that becomes something that's replicable for you and your practice, your learning, or just your passion for this area of environmental conservation and stewardship. So the Center for Academic Medicine provided this unique example of regenerative design in practice. Let's explore. Prior to development, Palo Alto, California was unspoiled coastal forest and grassland. Fast forward to today, and much of the Palo Alto lies beneath impervious hardscape. Impact of development has taken an ecological toll on Palo Alto, lowering its ecosystem performance and the health of nature and people. Seeking ways to engage nature for a new scientific workplace, designed for Stanford University's new Center for Academic Medicine, began by placing a circuit pilot below grade. This reduces the site's heat island effect and allowing for a more porous and restorative green space. The regenerative thesis welcomes nature from the adjacent arboretum into the medical campus, creating a community space of respite and rejuvenation. Solar modeling informs the building's shape and form, each wing sculpted to provide interior daylight while minimizing solar heat gain. The building's orientation and Palo Alto's mild climate allows 20% of the program to be placed outdoors. This reduces the building size and lowering its embodied carbon and its energy needs, ultimately achieving net zero energy. Open passageways draw in breezes and provide passive cooling, eroding these areas to create unique workplaces outdoors. Areas in sun and shade allow for a summer garden. Winter gardens receive sun and shade from the breeze, and the winter and spring and fall gardens activate all year round. Biophilic design draws from the colors, patterns, and textures of the arboretum. creating a sense of discovery within the interior environment. As the arboretum grows into the courtyard, the restorative impact of the development will continue to increase, improving the environmental health of Palo Alto into the future. Regenerative design with and for nature to the benefit of people and the planet. So I can pause there for a moment, Lily, if you want to ask me any questions, and then I can talk a little bit more about maybe some of the greater work that's to be done. And I think where the Biomimicry Institute goes beyond just buildings.
Yeah, I feel like I'd love to open it up. I'm sure one or two people have specific questions, and then we can kind of end with that, if that's okay, Sean.
Absolutely.
Yeah, do people have something? Like, feel free to unmute yourself and just talk. I see Jennifer has her hand raised. Do you want to? Oh, no. Who has a question? Just go ahead and unmute.
Hi, I have a question.
Hi, Tracy.
Hi, Sean. Hi, Lily. Hi, everyone. Wow, thank you. I'm a big fan. I've heard Janine present the Coast Guard project, and it always just gives me chills.
Yeah.
So I love all that you do. I am curious, and I am a newly hired person at a nonprofit called forester.org. And one of my initial projects will be to activate more of our greening program around the Miyawaki method.
Oh, yeah. Tiny forests.
Yes. So you do know about them. Wonderful.
Yes. Yeah.
Awesome. I want to follow up with you and the EIX organization, because we see a huge opportunity for everything you're doing, and then bringing in community engagement. Anyway, I'll follow up later, but thank you. I love this. I love the direction.
No, it was great. I'm only familiar with that process going back about a year.
Okay.
It's a little bit of what I'm showing here. You're looking at regenerative agriculture and permaculture. And then we just kicked off a phenomenal project that I'll share at the end of this at Catawba College. I was so enthusiastic to find a group of students there that were taking about a 1/4 acre of land and planting 200 bushes, trees, and plants this past weekend.
Where was this? Where in the world?
This is at Catawba College in Salisbury, North Carolina, about halfway between Charlotte and Greensboro.
I grew up in Raleigh. I know exactly where that is.
Okay, perfect. Yeah,
amazing.
2 hours west of Raleigh, or an hour and a half. Yeah.
And just for everyone's benefit, just the quick elevator pitch is 50 years ago, Professor Miyawaki pioneered, coming out of World War II, a method of densely planting the most shade-tolerant native broadleaf species as a sapling, and then around it densely planting other native plants. And you can biohack the forest succession process down from centuries to decades.
Yeah.
And there's a huge amount of opportunity for the planning, designing, and installation and ongoing monitoring for community participation and all sorts of good stuff. So
yeah.
Thanks, Tracy. Camilo, I see you have a hand raised.
I do. Sean, thanks so much for joining us today. Not yet, but we've been in communication because Lily has been handling everything as excellently as she always does. And I'm very glad to see a lot of young faces here to learning and becoming biomimics. So that's lovely. Here's one question. It's a very big question. Take it as whatever you want to take it. I'm just going to do it. Lily and Maylise, you've heard this question before. In your opinion, Sean, how does nature build a home?
Oh, it's a really good question. Well, the Coast Live Oak taught me a ton about that. So the number of different species that exist within that is massive. What's sort of interesting, having an earlier conversation today about biodiversity. We all want to save that, but it's actually one of the last kind of major measurements of how a habitat is doing. Right, when species thrive, you have a thriving habitat, which teaches us that, right, the first ingredients. How does nature build a home? Right, it begins with good quality soil. that's going to allow for not, flood to, dive deep into that water and, completely dampen it, or to be so densely packed that it just runs right off. It's able to have that right level of absorption, right? When that happens, right, everything from plants to trees can grow, right? The right type of smaller plants bring in a balance of insects, which allows for other slightly larger predators, birds, to come on in. As we start getting into bigger trees, that's that sort of cooling environment or warming environment, depending on where you exist within the world. I'm more speaking from the reference of the temperate broadleaf biome, but even in deserts, right? You can find habitats thriving as a result of the presence of water or the right balance of mix of sun and shade from wind, to allow some smaller species to really thrive. And so nature is continuously responding to the sort of the dynamic impacts of climate and the conditions of the ecosystem to enable living organisms to grow. Right? Where do people come into that? Well, we're just another animal in that mix, right? And the key question ends up being is that, do we maintain a relationship with that environment, or do we try and engineer beyond it? And every time we've tried to engineer beyond it, we've created damage, right? And there's always a little bit of a mix of, I understand in Dubai it's pretty darn hot, but people have thrived in the Middle East for thousands of years. But maybe we don't need to cool it down to 70, right? How can we do that a little bit better and more balanced in the same way? And some of the colder environments, maybe we don't need to be 80 degrees on the inside, right? Let's let nature and help shape those as vernacularly as possible.
Thank you.
Yeah, I love that, engineering with it or engineering beyond it. That's a quote.
Yeah.
Nayli, Stacey, you have your hand raised too. Oh, Jennifer, go ahead, Jennifer.
Oh, I do actually have so many questions. Thanks, Sean.
Yeah.
I'm an architect in Seattle, and I'm a biomimic, and I've been integrating biomimicry into work for quite a while, and or
Awesome.
trying to and advocating for it.
Yeah.
And I'm curious. I think the real sweet spot that you were hitting on immediately is maybe less about mimicking the function of particular organisms and really looking at the whole system. How to a lot of the work of the Institute has done as well. I still find it so difficult to keep the big picture in mind. How do we think really like nature? And even thinking about systems, we did some work years ago that's specifically about evaporation in the Pacific Northwest and how to mimic that and how to our buildings evaporate the way the Northwest forest does. But that's just one little piece of it. And so as we do that and as we advocate for that, we're missing the whole rest of the system. And so I wonder if you have any tips of how do you hold everything all at once when human beings, we can't do that, but nature does that so beautifully.
Yeah,
how do you manage that?
That's a great question. I don't know that I have completely solved it. I think what I can respond to is very like, how do we try and go about doing it? I think the first one, just to almost remind ourselves to be humble. We can only do so much individually, right? So on any of these projects, right, there's a continuously lesson learned. Like we only get so far with any one of these projects, and we kind of go, okay, cool. We have solved that challenge. What else can we layer into it? And so that's a huge piece of our work. It's a huge way of how nature functions as well, just layering solutions on top of each other. Trying to be cognizant of the system when you are working not on every element of the system. And I think, great examples here, airports, sports stadiums, hospitals. These are big infrastructural giants, technical engineering feats that for the most part kind of say, let's put nature outside of it, right? They don't often want nature to be involved. And I think the tough thing with those is actually really trying to engage people to sort of maintain that sort of center of it. And so is there, beyond the goal and intent of trying to create a regenerative impact, are the things that can consistently maintain social awareness to it? Because you have to reinforce that mission, right? If it just becomes this consistent ultra marathon, people will lose energy unless it is at the core of everything you do. And you've got to get hundreds of people involved towards that solution. And so are there other things that we can learn from nature, from the habitat that create biophilic opportunities, that reinforce the other missions that the infrastructure project has, right? A hospital wants to be a healing environment. Nature provides great healing benefits. And so sometimes just trying to abstract those out and create those spaces on the interior of a hospital helps reinforce the mission of what you're trying to do for the habitat. For an airport, right? They are the gateways into every place. And right, while a runway says keep birds away because we all want to safely land, not that far from it, you can use birds of prey, you can create forests that tell you where you have arrived in the world. We're working on the first net zero energy airport in the US at Monterey. It's the first time we've actually had a positive impact on nature. We're not regenerative, but we are restorative at that airport because of how and where we've planned nature into it. And so, right, summing that up for you, I think it's, noting that, like, take every win and keep building on it. Don't get frustrated by the losses that you didn't get all of it done. And secondly, just always try and find ways that the mission of this can reconnect back to everyone, because you have to pull people along with it.
Thank you.
Yeah. Thanks, Sean. Maylise, please go ahead.
Thank you. And thank you, Sean. I have two questions. One, so I'm based in LA in California, and I'm getting more and more familiar with like everything related to like permitting here.
Yeah.
And usually bridgeable buildings are not quite the cookie cutter type of building. And I wonder like if you come across any like difficulties on projects due to like the very unique nature of these buildings. And the second question is, have you come across any like interesting strategies to share that local knowledge with like local governments or like other architecture firms, and kind of like, the balance between like keeping the value that you bring, of course, to any like new project, but also like the value of like bringing that knowledge?
Yeah, so I'll break that into two, right? Are there any barriers that we find through permitting or regulations to this work? And similarly,
and how to like move projects forward.
How do we move through that? Or are there any wins that we can use that unlock some of those regulations or speed up the adoption of other ones? Water's the most challenging, right? If anyone has tried to do a net zero water project, you have at some point investigated, how do we get people to drink the rainwater? Or how do we reuse water in a place where people are going to interact with it? Right? Every jurisdiction is going to have to immediately face that question and say, how can you ensure safety? Right? Children are going to play in that landscape. If people are drinking that water, how do we confirm that? And so, it has been the biggest barrier that we have seen. And there are a couple of projects through the International Living Feature Institute that have achieved net zero water. There's been some wonderful work done at that level that we haven't been able to get to. And so those are the first ones that sort of at least show a blueprint. But it takes a lot of time to get a regulatory body to adopt a new standard or to begin to trust some of those systems, and especially a lot of those technologies are new. In certain cases, they go away. So I still see that water really being the longest term one that we're going to have a tough time getting through. Stormwater management, in the contrast, is where we're starting to now have, I'd sort of say, 15 to 20 years of really good evidence, where we've switched from doing cisterns or concrete canals to demonstrate how riparian edges or more natural thoroughfares or wetlands can be planned to move through, filter, and circulate water. And that for us has begun at some more smaller scale things. Before we did the U.S. Coast Guard headquarters, we did the World Wildlife Foundation headquarters, and we had some very small wetland areas around that. And that taught us how to do it big. I was with HOK, then I should say that's how it taught HOK. I learned from it secondhand. And then the third one is, I guess, would be sort of like, how do you use that to propel things forward? So I'm in California as well, and I'm always surprised that there isn't still a requirement yet for natural open space. And actually, if you look at the Cal Green codes and rules, there's actually even a line item for it. It just, there's no information after it. Natural open space is a line item that's blank. So there's a draft requirement that hasn't been written yet. And so as we begin to start working on some of these master planning projects that are demonstrating that restorative rate, we are trying to go to the Department of General Services in California to show that benefit. We'll be working with the American Society of Landscape Architects to show that benefit and hope that they will make some of those channels. We'll be beginning to communicate more and more those successes, because we want and hope that regulatory codes, much like energy use or water efficiency, start to be written about natural systems instead of what we currently see within the NEPA, National Environmental Protection Act, which is essentially a notion of do no harm. We actually want to start seeing codes in the next decade that say do good. Like, if you've got the money to develop this property, do good.
Thank you so much for.
Yeah.
Thanks, Sean. Any last questions from folks? Feel free to pop something in the chat or just unmute yourself. No? Anyone thinking about it? I don't see anything in the chat. So yeah, I think maybe I'll ask one ending question. And I love this question. It's pretty generic, but what are you really inspired by right now, or what's giving you hope? I feel like the world is frustrating and continues to be frustrating, but this work is so powerful and impactful. I'd love to hear from you just kind of as we're wrapping up, what's giving you hope?
I'm gonna share 3 slides for that, because I just came back from, I think, the best project kickoff that I've ever had, and it's at Catawba College in North Carolina, and right, that's a part of the country that is, we'll sort of say, right of center. It is a very purple place, and what was really interesting here was finding a community both at the college level and at the city level that really wants to be more engaged with the environment. And I think fundamentally, when we do start talking about an era of distrust that is forming, especially along political spectrums across different segments of countries or worlds, I think everyone has a grounding and fully connecting memory around nature. I think anytime we go into a place like that and we try and reinforce the culture of a place and its heritage, we try and reinforce opportunities for local jobs and for a community to thrive, we create a fairly defensible, spectrum to everything else, right? And it's maybe teaching us a little bit about how do we voice some of these ideas. I'm talking to most of you all how I would normally talk. But oftentimes when I go into these areas, I have to be a little bit more trained, right? Stormwater management and resilience, I might, have to massage some of those words so that an audience might be more ready to hear it. And sometimes it gets boiled down to insurance risk mitigation, boring stuff. But I was really excited last week over the course of 3 days to meet with students, faculty, staff, the president, donors, community, and city officials in this area in Salisbury, North Carolina, that started to take on this point of view that what we could do in this one central spot of the campus could have impacts beyond. And it began with, I think, perhaps a really good lesson learned over the years, which is ask more questions and tell less. And so hear from people what they want. And so despite all of the noise, there's a message of what people really are looking for. It's just being bent one way or the other, radically or conservatively. And I think it's really an important thing for us to use this time to try and find ways to unify people. And so I guess to answer your question simply, I think the inspiration I have right now is trying to figure out the right way by which nature helps create a community. In this case, at Catawba, creating a campus for us. That's a really important thing for us to always be thinking about. How do we bring people back towards the middle, towards uniting with each other?
That's a beautiful place to end. Thank you so much, Sean. And thank you so much, everyone, for joining us.